Hello everyone, this is Math 1332, Chapter 3, Logic, video lesson. I'm going to start off first with Section 1. Section 1 deals with statements, negation, and quantified statements. Okay, we'll begin by first. In English, we use a whole bunch of different types of sentences. Some of our sentences could be true or false. And that's going to be pretty big for us in this time. Others tell us of opinions. They ask questions. Or they make exclamations. These we cannot use. In logic, we only use statements. Not opinions, not questions, not exclamations. We use statements. A statement is a sentence that is either true or false, not both. If a statement is true and false at the same time, it's called a paradox. A paradox is a statement that is true and false at the same time, which doesn't exist. Now, when we define sets, we use capital letters to define sets. Here we use lowercase letters to represent statements. Typically we use Q, R, P, S, T. We typically use those letters. Look up examples. Statement P. Dallas is a city in Texas. Q. Arthur is my first name. Why are both of these statements? Because they could be determined whether they're true or false. Is Dallas a city in Texas? True. Is Arthur my first name? Yes, it's true. So again, we defined this statement with that letter. We can also negate, is make a statement change from true to false or false to true. Now, and when we talk about negation, we use the tilde. It's the tilde sign. On your computer, that is to the left of the number one button, number one key. You hit shift and the button to the left of number one, there's a squiggle, the tilde. It's read as not. So, for example, here originally we had P. It said that Dallas is a city in Texas. If I make it not P, then we negate this sentence with Dallas is not a city in Texas. So that's how we negate it. We're looking at the Dallas is that a true statement or a false statement? No, it's a false statement because it's the negation of it. So this is statement P. This is statement not P. All right. Also, we talk about quantified statements. Okay, quantified, yes, quantified means numbers. But not in the numerical senses we're talking about. When we talk about quantified, we either talk about all, some, or no, or none. It's a general quantification. Do we talk about all, none, or some? These are quantified. So whenever a sentence has one of those words, it is now a quantified statement. Here's some examples. Let me create a table here for you. All right. Here's the statement. Here's an equivalent statement. Okay, what that means is the same as, it's similar, but it's written just a little bit different. And I'll try to give you an example. So, all P are Q. Now, using an equivalent, I'm going to be using the negation symbols. It's going to say there are no P that are not Q. So, for example, all Texans are Texans. all Texans are in Texas. There are no Texans that are not in Texas. Another one. Here's another quantified statement. Some P are Q. The negation of that, which makes it also the same statement. There are there exists, because we're talking about some. There exists at least one P that is Q. There exists at least one P that is Q. For example, some dogs are short. I'm looking at my dogs. Some dogs are short. So another example would be at least one dog is short. There could be more, there could be none, there could be one, but it has to be at least one. No dogs are cats. All dogs are not cats. Just remember, we're dealing with the negations here. I'm sorry. It's just that no P are Q. All P are not Q. No P are Q. All P's are not Q. So, no dogs are cats. All dogs are not cats. I'm sorry about that. It's just thinking ahead. Some P are not Q. Or not all P are Q. Some dogs are not short. Not all dogs are short. Alright, so yeah, the table here, keep it to access because you'll need it when we start doing some of the homework. So these are just the statements and the equivalent negation statements. So here's a statement, here's a negation statement. They're the same thing. They have the same truth tables as we'll do later, but here's examples of them. All right. Now, if we notice here, there's a commonality. the negations and their equivalents. Here's a better way of looking at it. All P are Q. And here's the negation we have in that negation. There are no P that are not Q. Let's look at the next one. Some P are Q. And the negation of that one is there exists at least one P that is a Q. Alright, let's look at the last two. We have no P are Q. All P are not Q. Some P are not Q, or not all A are not all P are Q. Now, what does this table represent here? The negations of them. These are negations, the equivalent statements, but the negation, the opposite. The negation of all P are Q is some P are not Q. Those are negations of each other. The negation of no P or Q is that some P are Q. So these are the negations, the opposites of them. Alright, so now we'll start doing the homework.